Okay, let's continue our coffee example. Now, in our previous video, we have calculated that our p-value is 0.045. So, we have p-value equals to 0.045. We used alpha equals to 0.10. We reject h now. What if our alpha is 0.05 or 0.01? So when our alpha is 0.10, we reject h now. When our alpha is 0.05, our p-value is less than the alpha, we still reject h now. When our alpha is 0.01, then our p-value is greater than this alpha, so we could not, or we fail to reject h now. So you can see that if you are having the exact same data, and you're having the same t, the same n, you are having the same p-value, but when your alpha is different, your decision about your hypothesis test is going to be different. So the significance level, that is the alpha. You still remember what's the name for the alpha? That's called significance level. It's like a line in the sand. So for the same data, your decision depends on where you draw the line. So you need to decide your alpha before you start your hypothesis testing. Remember, we also mentioned that if you are skeptical about HA, you'd better choose a smaller alpha. Here you can see if you are skeptical about your HA, when your alpha is big, you reject H now. You are in favor of HA. If your alpha is small, here alpha is 0.01, then you fail to reject H now. You are in favor of H now. So if you are skeptical about your now, if you are skeptical about your alternative hypothesis, you'd better make your alpha small, so it's difficult to reject H now. It provides a stronger protection for your null hypothesis. So the next example, also about the coffee example. Suppose I was concerned that the mean caffeine content in a cup is really different than 60 milligram. So now it's different from 60. I'm not saying it's less than 60 or greater than 60. So this is a two-sided test. So it's going to be very similar, so I'm going to simplify it. The first step is establish the null hypothesis and alternative hypothesis. The null hypothesis is always going to be with the equal sign, and the alternative hypothesis is what's the research question is. Now, we are suspecting that mu is really different from 60. So the alternative hypothesis is mu not equal to 60. The second step is the same. We are going to have the same test statistic. The third step, to find out the p-value. So now our distribution is the same. It's just our p-value is going to be the area under the curve that is on the right side and the area under the curve that is on the left side. So it's for both directions and they are symmetric. So it is so these two probability are going to be the same because it's symmetric. So it's going to be 2 times the one-sided p-value, which is 0.045. That gives us a 0.09 here. So this area is 0.045. This area is 0.045. That's what we have calculated, and they are symmetric. So the total area is 0.09. Now our p-value is 0.09, so we could make a decision that the p-value is less than our alpha equals 0.1. So we reject H now. So this is how you would do the same hypothesis testing. The only difference is now you are having an alternative hypothesis mu not equal to 60. I'm not going to show you how this would be for an alternative hypothesis mu greater than 60, but I think you should have no problem finding it out. So that's the end of this lecture.